We are working on topic 2.3, transformations of functions today. Our essential question is, what are the ways you can transform the graph of the function f of x? And then you're going to write 3 I can statements today. They're all very, very similar, but we want to be able to connect them to separate questions. So we wrote them as 3 I can statements. So I can transform a function using a translation. I can transform a function using a reflection, and I can transform a graph using a stretch or compression. If you need to, go ahead and pause to write those down. So investigating translations of graph functions. So we're going to do explore one right now. You can transform the graph of a function in various ways. You can translate the graph horizontal. So the word translate is important here. You can translate the graph horizontally or vertically. You can stretch or compress horizontally or vertically again. And then you can reflect the graph across the x-axis or the y-axis. So how the graph of a given function is transformed is determined by certain numbers called parameters. Then they're introduced in the function. So in this case, the graph, the first graph, g of x equals f of x plus k, where k is the parameter. So that's the parameter. Let k equal 4 so that g of x equals f of x plus 4. Complete the input and output table and then graph g of x. In general, how is the graph of g of x and f of x related to the graph of f of x when k is a positive number? So it said that I had to add 4. So basically what happened here is they added 4, they got 2. They added 4, they got 6. When we add 4, we get 2. When we add 4, we get 6. Now let's go ahead and plot that. So we're going to use this x value and this y value. So out -1, up 2. Out 1, up 6. Out 3, up 2. And out 5 and up 6. And then if I connected those dots, and you'll notice that basically it went up that many units, right? If I look at this, 1, 2, 3, 4, I could be at any point on the graph, 1, 2, 3, 4. And we know that the graph shifted up or translated up 4 units. So we could say when k is positive, g of x translated, and you might want to put, because this is your notes, or shifted. Shifted is another good word. Up 4 units. All right, now we'll try a negative value of k. So this time they're using let k equal to -3, and we'll do this in a different color. So this time we're subtracting 3. So they subtracted 3 and got 5, subtracted 3, got -1, subtracted 3, get -3, subtract 3, get -1. We're going to use this x value, this y value to plot. So we're plotting -1, -5, 1, -1, 3, -3, 3, -3. Something doesn't seem right. That should have been -5. Thank you. -5. And then -5, -1. So this is our picture this time. And you'll notice this time the graph moved down 3 units, and it doesn't matter where on the graph I pick that, it's always 3. So this time, so when k is negative, g of x translated or shifted is fine, down 3 units. All right,